Kajeko mo Made in SA, re kopana le Jason. Jason o bala aerospace engineering ko Wits University. Basically, this is the science of everything that flies. Jason's dream is to design and build his own aircraft. Jason is fascinated by digital toys. He's a gizmo guy, and he has an adventurous side to him, extreme sports. Today, Jason gets a first-hand experience of life as an aerospace engineer. Made in SA, where we celebrate young people of excellence and give them a taste of their dream career.
My name is Jason Malongo. My dream is to become an aerospace engineer. Aerospace engineering is the study of flight, the study of anything that can fly, whether it's birds, whether it's planes, whether it's paper. Anything that can fly, that's aerospace engineering. I love to go down to the airport and watch planes, just to see them take off and land. I find that something phenomenal. At the moment, I'm studying aeronautical engineering at the University of Witwatersrand in Johannesburg.
The kind of personality is required to be a good engineer, generally speaking, is to be able to communicate and to share, his ideas with your colleagues and friends.
Professor, you said supersonic? What is supersonic?
Supersonic is, when you are going to fly enough and when you can hear, a bang. So in fact, you are above 1,000 kilometers an hour.
Yeah. Supersonic.
Supersonic.
Oh,
yeah.
okay.
So what stands out for me for Jason's, first of all, is clever, because it's something which is important. He knows what does it mean in engineering, and he's very open-minded. He doesn't stop, about anything. He will always try to find, solutions, to talk with people. This one is very important.
My other dream is to start one of the greatest technology companies that creates solutions for education, for government in our country and also up in Africa. I'm working with my friends whereby we started a company where we design mobile applications for devices like the iPad, for Android phones and Blackberries.
Jason and his business partner, Fuad, have been working on a project that they want to present to potential clients. Today is the big day.
So we've got the library, do the digital, presentation's looking good.
Yeah.
Think we're ready?
We think we're ready.
All right.
Team Funda, let's go.
Let's bring the rain.
Okay.
Let's go. I enjoy him as business partner because he's a man of action. He shows initiative. The one project that he invited me to, Blue Uni, was, I never thought of it, but he spoke to me about it and, he got me interested, persuaded me, and we started getting things going. So definitely a man of action.
The company they want to pitch to is Macmillan, a publisher of educational materials. Good luck, guys.
Just want to thank you very much for this opportunity to present as Blue Uni to you as a publisher. And what we have for you is a presentation on something that we believe will be crucial to the learning environment in the country.
What I really like about Jason is that he seems very shy when you first meet him, but that goes away completely as you get to speak to him more and more. He's an incredibly confident person, and I think that's fantastic because lots of IT people like to bamboozle you with big words, and he's so comfortable with his subject matter that he makes you relaxed, and he's fantastic.
We also have the functionality of highlighting, adding stickies, and we have Smart Links. Smart Links is a section that allows you to put information there, additional information by your teachers. So teachers can add information for students, and at any time the student can come back to that and get their teacher's own additional notes.
Stickies? Talk to me more about that.
About stickies, okay.
Yeah, I like that idea.
Okay. Our competitive advantage is definitely our stickies. If we go back to stickies, what we have here is stickies and highlighting is all a form of annotation, as well as smart links. And the smart links that you select with your stickies and your highlights can all be compiled into a journal. And at any stage, you can come back to that journal and page through all the notes that you made.
I think he showed us why his platform is different to the other ones that are out there. He made us very interested in some options that are that give a lot more than some of the others that we've looked at. I also think that he shows the enthusiasm that it's really sold to us. Yeah.
At the moment, I'm quite filled with joy. I'm ecstatic. This is our first publisher, and they bought into it straight away. Thank you very much, Bernita. Thank you very much, Karen.
Thanks.
Okay.
Thank you.
Okay. I'm planning to relax after all of this by going to grab an energy drink and going rock climbing. Hey! Happy Easter!
Oh no. What's happening?
What's up? How are you?
How you doing? How
Good
you
in
doing?
here?
Pleased to see you,
Good,
man.
good.
How's the day been?
Ah, no, day's been good. We actually just came from a power meeting. Well done.
Tell me about it. How was
Yeah.
it? How was it?
Ah, aced it.
Huh.
Yeah.
You did well.
Yeah.
Huh? Got clients on board.
Yeah, man.
That's what I like
So,
to hear.
ready to get some
I'm
de-stress.
ready. Let's go.
You can't put Jason in a box, that's one thing. Jason's a unique character. You won't find someone like Jason anywhere in the world.
Good question. The middle has the broken harness.
Okay, cool. Jason's a hardworking guy. He's got a lot of vision. He's one guy who's willing to make things work. He'll stick it out through the good times and the bad.
Let's go.
Giving you a head start, guy. He deserves a lot of good things that will come his way because he works for it.
The physical pleasure I got was my forearms are burning now. Feel great. As I got to the top, it got harder. My fingers got sore, my forearms were swollen, and I just remembered that I can use my legs, and I managed to get to the top. Well done. Fuzi, well done.
This one here.
Cool. All right.
Coops, you can try that one.
If I get to the top, can I put my initials there?
Oh yeah, that's
After the break, Jason meets his maiden SA coach, who introduces him to the real world of aerospace engineering. He'll be given some awesome challenges to test his love of the science. Stay tuned. Before the break, we met Jason. He studies aerospace engineering at university. His dream is to design and build his own aircraft. Now that we've got to know him, it's time for a challenge. Jason is about to meet his maiden SA coach. Take it away, Jason.
I'm really excited because today I'm meeting my maiden SA coach. I'm really nervous because I've got no idea what's going to happen today, but I'm also excited in the way that I know that I can make an impression here at the CSR for when I graduate.
My name is John Monk. I work at the CSR as an aeronautical engineer. The aeronautical engineer does lots of different things. Typically here we do aircraft design or unmanned aircraft design. We might be involved in stability and control predictions, performance prediction work, flutter predictions, flight testing, a range of various aircraft-related topics.
Jason, hi, I'm John Monk. I'm your maiden SA coach. Welcome to CSIR.
Hi John, pleased to meet you.
Let's come through, see what we have in plan for you.
Okay.
So Jason, I understand you're studying aerospace engineering at WITS.
Yes John, that's correct.
And how's it going?
I'm loving it actually. I'm doing my best to fly high.
Good, excellent.
When I met John, I could see he was a very talented, very intellectual and smart gentleman. And he's quite polite as well. So John, tell me, what do you do at the CSIR?
Well, we do lots of research and lots of different technology areas, but largely unmanned aircraft and simulations.
Tell me about unmanned aircraft.
It's UAV is the term we use in the industry now, or unmanned aircraft system, UAS. It's an aircraft that's flown by autopilot. There are no pilots inside, and they typically fly missions that are what's called dull, dirty, or dangerous. There's long missions dangerous missions, or missions where they have to go in places which are not safe for the pilots.
What type of unmanned aerial vehicles do you have?
We've got 3 research platforms here. We have one called s01e, which is a research platform for unstable aircraft design and autopilot control. We have one called Indiza, which is a 2-meter span hand-launchable UAV as a demonstrator. And we have a UAV called the modular UAV, which is really a large research platform, a 4-meter span, twin fuselage airframe. And in fact, your challenge will be working on it this morning.
Wow, excellent.
Should we go?
Sure.
Okay, Jason, what we're going past now is called the medium-speed wind tunnel. It's one of the biggest wind tunnels we have here, or the biggest wind tunnel we have here, and all part of the national key point. I'll take you through and show you what we have.
Excellent.
Right, Jason, what we have here is the medium-speed wind tunnel. This is our largest wind tunnel.
Okay.
Wind tunnel being a big test section, a big test facility that we blow wind around and we measure forces on models and predict the forces on the full-scale items. So let me show you what's in the test section.
Okay.
Oh dear, boys and their toys. Let's see what the wind tunnel can do.
Right, Jason, this is the test section of the wind tunnel now. This is where we install the models and we do the actual tests on the models.
Okay. What model is that you have installed?
That's a Cheetah C. It's a CNC machined model. It's made out of stainless steel because of the high speeds in the tunnel.
Okay. What speed are we going to be testing at?
This tunnel can test to way past the speed of sound.
Wow.
But typically most tests we do are around about the speed of sound.
Okay. Right. Where do the results come out?
They come out in a room off our left. I'll come show you now.
Okay.
Good. Okay, so this is the control room. It's where we control the tunnel from and control the speeds and the pressures and everything else. And we have a video that you can see what's happening in the tunnel. Oh, and nice. All the results of the tests get displayed here as the guys are testing.
Okay.
Right, Jason, this is s01e I spoke about earlier. This is the research UAV looking at unstable platforms.
Where do you use s01e?
s01e was built purely as a research platform, so the actual airframe was designed by a computer. The teams here set up a number of computer simulations and they used Optimizer, and that spat out this geometry. Once they had that, it gets CNC machined and molds are made, and this is a mock-up of the actual flying airframe.
Very nice.
This is Indiza. This is our demonstration UAV. It's been tested in the wind tunnel, it's been characterized in the wind tunnel, so we have data of the actual drag and lift that the aircraft produces. And we use this as a demonstrator for the autopilot that we use, and as a platform that universities are welcome to borrow and to try out their research on.
Okay, very nice.
Okay, shall I show you the modular UAV?
Thanks.
Okay, Jason, this is the modular UAV or unmanned aircraft. This is our main research platform now that we use. In fact, your challenge will be based on this.
Oh, nice. Why such a peculiar design?
The design came from a number of requirements from various universities and ourselves to do research. And one of the requirements was that you'd have no single cause for failure that would bring the airframe down. So we have 2 fuselages with 2 rudders, 2 elevators, 2 motors, and finally 2 autopilots. And so if either one fails, the other one can take over the control of the flight and bring the airframe back.
Very nice. How many engineers did it take to design this?
It would have been about 5 engineers over a space of about 7 months.
Wow.
This morning he came across as very enthusiastic and very keen to get involved in the work and the challenge we had for him.
Right, Jason, okay, we've taken you through the wind tunnels to see what we have here. You've heard about the unmanned aircraft we have and you've seen them. Your challenge this morning really is to help us on the modular UAV. And the challenge is that we've added a camera system to the payload pod that changes the center of gravity of the aircraft. We'd like you now to do some calculations to work out where the center of gravity should be on the aircraft to make sure it flies safely and stably. So what you're going to be doing is to do some predictions of where that balance point should be, and then we'll put those into a simulation and you can try and fly the airframe
and then we'll know then we have a safe position.
Excellent.
I think Jason was probably a little terrified by the thought of having to do something that he hasn't done before, possibly with terms he hasn't heard of before, and with software he hasn't seen before. Good.
I look forward to it. As soon as John told me the challenge, I got a fright in my head. I was like, can I do this? Will I be able to do this? But I just said, calm down. I'm passionate about this. I understand aero. Let me listen to what he's telling me. Let me listen to the clues he's giving me. And let me just give it my best.
When Made in SA returns, Jason heads for the wind tunnel to test the UAV to get the data he needs. Will he succeed in getting his craft to fly? Join us after the break. Welcome back to Made in SA. Earlier, we met Jason, who dreams of designing and building his own aircraft. Jason is about to test his UAV in the wind tunnel. But first, it's up to his coach to set Jason up for the challenge. Take it away, coach.
Right, okay, Jason, what we've got here is an open source program, in fact, that does predictions on things like the wing performance, the performance of the tailplane, performance of the vertical fins. If you combine the whole lot into one simulation like this, you can actually determine the overall stability or how stable the UAV is going to be. So what we're going to do here now is ask you to enter some data that will help us determine the stability. And to do that, we go into the input file, we modify the predicted center of gravity point, and we look at the results.
After I received the challenge, while we were sitting down by the computer, we were busy running through the simulation. He was showing me how it works. He was showing me what values I can input, and he was showing me where I see the results. And then he also showed me what I need to compare to be able to say, this is the speed that the plane will fly level.
Put up the right file here of the aircraft. That's the geometry of the aircraft.
The control surface sizing.
Change that so we can go back one.
Right from the word go, he made sure I understood everything. He walked through all the steps with me. He did it slowly. He picked up pace where he needed to. And he was also quite enthusiastic. And he's quite a happy guy, and that made me happy and made me feel calm.
Right, okay, so Jason, you understand what you need to do there. So you're going to change your moment reference location, which is like a center of gravity.
Okay.
And then do those simulations, get the stability out of the pitching moment curves, and I'll come back and see how you're doing.
Okay.
Good, enjoy.
Thanks, John.
The first simulation we did was a simulation of the wings and the tail on the unmanned aircraft to work out the stability and to work out where to balance the airframe. Having taken that data out and inserted that into the flight simulator, we could then go and fly the airframe with what we call man in the loop. So Jason had to fly it physically in the simulation. And from that, he could get a feel for what feels stable and what feels unstable. And as it turned out, what he first predicted with the simple simulation we did was slightly unstable.
After running the simulation, we realized that there were a couple of problems. And this usually happens because theoretical analysis isn't always the best. So that's why we had to go to the wind tunnel to get some practical, real-world results and predictions.
A wind tunnel is the only way to test if a design is as good in the air as it is on the screen.
The fans in the back there, they suck the airflow that comes through from the front. That blows over the model, that's installed already for us. And then the balance inside the wind tunnel model in the payload pod measures the loads that we need. And that data then gets taken through into the control room.
This is exciting stuff. With the wind tunnel on it, it will be easy to see the effect that the load has on the design. The control room has all the gizmos to record the data. So guys, let's get onto the test.
Jason, this is Peter Skinner, our wind tunnel test engineer.
Hi, Peter.
Jason.
A wind tunnel test either confirms the results that you simulate by the computer behind your desk, or it tells you that those results are wrong and it gives you better predictions or better results.
The data from the wind tunnel balance gets ported through into this room, into the computers that we see over here. So what we'll be doing is looking at data over here, which we'll extract in for the flight simulation to get more accurate values in there.
Okay. Are we getting real-world data here?
That's the idea. The idea, we actually have the motors in the wind tunnel, in the model rather, with propellers running. So we'll get propeller blast over the tail that'll affect our readings, and we'll take the power on data that we were missing from the simulations, put that in, and that'll give us a more accurate flight model.
And then we take the answers from here back to the simulation.
That's correct.
Okay.
Yeah. Okay, Jason, look, there's the result now we're looking for. That's the difference now between what we had before without the power effects. And from the wind tunnel test, we now have that difference. Let's go put that number back in the flight simulation and see if it's a more stable aircraft.
Okay, let's
Good?
go.
Great. Jason has almost a perfect personality. He has a passion for aeronautics and for aircraft, and an understanding of what's required. And I think that's very important. You can have somebody who's got a very high mark in the sciences, but without a passion for aeronautics, very often doesn't understand or hasn't read up in the background and doesn't have that broader feel for aircraft. And Jason seems a lot more knowledgeable than the average student going into his field.
Okay.
All right, and then let's run a simulation now with a new balance point. Let's see how it flies now. How's that feel?
Wow, much better. This is great.
Look at that. Yeah. Feels a lot more stable now, isn't it?
Right. And when I push it nose down, it comes back up.
That's it. That's great. You've basically met the requirements of the challenge. Well done.
Thanks, John.
Excellent, Jason. That was very well done.
Okay.
Congratulations.
Good. From my experience today, I learned about the hard work that goes into making small things such as UAVs. So now it makes me think about, what about when I design the big commercial aircraft? It makes me think about all the hard work, the teams that I need to work in, as well as I got to understand a bit of the software and the real-world testing in the wind tunnel that goes behind making these aircraft fly. Wow, John, I've really had a great day here. Thank you very much for having me. I appreciate it.
It's a pleasure. You did very well. I'm actually very impressed.
Thank you, John.
I'm glad you enjoyed it.
Okay.
Okay, go well.
Thank you.
Yeah, cheerio.
Cheers.
Bye-bye.
After today's experience, I am more convinced that aero engineering is for me. I've seen the results of the hard work that we put in. I've seen the UAVs. I really feel that this is something I want to be doing.
Next week on Made in SA, we meet Rebecca. She's 16 years old and from Johannesburg. Rebecca's dream is to become an investment entrepreneur, and today she will learn all about how to approach an investor and her business ideas. If you are a young entrepreneur and wants to get investors to help you start your business, then next week's episode of Made in SA is just for you. See you then!